I want to start this talk by saying one thing, and that's essentially the goal of the talk. And what I want to achieve with this talk is essentially to scare you when you use Kubernetes. I want to have your fingers trembling on the keyboard every time you touch Kubernetes, and really think about what you're doing. Maybe a short introduction of myself. I'm Jakob Beckmann. I work at IPT. It's a small Swiss consultancy company, and for the last 1.5 years to 2 years, I've been working for the Swiss government on their internal clouds. We work mostly on Kubernetes and providing services on it. So let's get into Kubernetes hacking. First of all, why do we care about Kubernetes security? I like to take this story to illustrate what problems can come up with Kubernetes. And essentially, in 2018, Tesla accidentally configured the Kubernetes in a way that allowed hackers to gain access to it and perform crypto mining on their entire infrastructure. And the fact is, the thing that they did wrong is something super basic. It's like the most basic misconfiguration, and it's essentially they exposed the entire cluster online, and you only had to go to the website. You didn't have to log in or anything, and you get access, or you got access to a full dashboard that essentially allows you to get administrative access to the cluster. And the hackers essentially used this to do crypto mining, which is a bit annoying because you pay for resources for people to mine Bitcoin or whatever, but it's not actually that big of a deal considering what could have gone wrong. Because typically, Kubernetes is integrated very tightly into other systems. So potentially external systems that you use, for example, an S3 bucket or S3 service on AWS that some application within your cluster needs to access. And in order to access this, you need credentials, and those credentials are managed by Kubernetes. So you might get much more access than just the boundary of Kubernetes by hacking into it via information that is exposed in there. So what are we going to do today? We're going to look at an attack vector, a multi-stage attack vector on Kubernetes, and how essentially a small vulnerability inside an application that is running on Kubernetes can essentially lead to someone owning the entire Kubernetes cluster. And we're not going to look at something as basic as exposing it online, because that'd be pretty boring. But before we start, maybe a small disclaimer. So I'm not going to do an introduction to Kubernetes, so if you have no idea about Kubernetes, then I'm really sorry, because it's going to be very difficult to follow. And the second disclaimer is, please use this knowledge responsibly and don't go hacking other people's clusters, because that can be illegal. And so the way we're going to do this is essentially we're going to go through each step, look at the vulnerability and what problems it causes, how we can exploit it, and then how we could have protected ourselves against that vulnerability. So a small Kubernetes cluster might look like this, right? Obviously, in reality, it's much bigger, but conceptually, it's essentially this. You have several nodes, worker nodes that essentially perform your workloads on which pods run. In those pods, there's containers. And then you have a control plane, so one or several master nodes that essentially run the Kubernetes API server, the scheduler, the controllers, and might also potentially run pods, especially in smaller containers, smaller clusters, because people try to save resources, and we're going to see also how that can be a major problem. But this is essentially our abstract vision of the cluster and that we're going to act on. So before we start the hack, we need some point of initial access, right? This is the only part I'm going to fake in this whole attack vector, just because it's easier than to follow what we're doing. But we're going to take advantage of a remote code execution vulnerability. And some people might already be like, okay, remote code execution vulnerability, that doesn't happen to us. I mean, come on, what's the likelihood? But the reality is we all develop code, and when you develop code, you're bound to also develop bugs, and those bugs can be used to generate vulnerabilities like remote code execution. And even if you're the perfect developer that never writes bugs, there's supply chain attacks, right? Stuff like the log4shell vulnerability. So you might write perfect code, but you just happen to use a log4j version that is vulnerable to it, and then you have a remote code execution vulnerability in your application, period. It's how it is. And As a matter of fact, for the last 8 years, I think it's 8 years that it's been vulnerable, you had a remote code execution vulnerability in your code base if you used Log4j version that is vulnerable to this. But here we're just going to fake it and essentially perform an execution into a pod and pretend that we do the remote code execution. This is just for simplicity so that we don't need to do weird stuff to essentially get our code to execute, but it has the same effect in a sense. So essentially we just pop a shell on a container that happens to be in a Kubernetes cluster. At this point, in theory, we wouldn't know about this yet, right? We just hack an application that's online, it's exposed online. We don't know that it's running in Kubernetes, but we get a shell, and we can start exploring already a little bit. We can figure out, okay, what user are we running inside, whatever construct this is, so it might be a VM, might be a container, right? We don't know yet. And where are we at? So this is like super basic stuff, right? Here we already see the first problem we're running is root, which is already an issue, and we'll get to it in a second. So at this point, we don't know yet that we're in a container, but we are in that little red container. So yeah, we isolated from the cluster. It's not that big of a deal at this moment. We only have the application itself that is affected. So how could we have protected ourselves against a remote code execution vulnerability? This has nothing to do with Kubernetes, right? But code scanning is always a good thing. You can use image scanning when you use containers and Docker images, obviously, which is very useful, especially for supply chain attacks, so that you can essentially scan dependencies that are contained in your image that might not be dependencies that you pull from your code, right? And finally, the use of safe languages. I put this in apostrophes because there's no such thing as a language that you use and it's safe, but there's languages that are more safe to use within containers than others. For example, languages that tend to, or that compile to like binary codes tend to be safer because you can encapsulate them much better in a container than languages that use virtual machines or interpreters to run. Now we get to the interesting part. So we have that shell open, or however we gained access to the container via the remote code execution. Now we start exploring. We start figuring out, okay, what's in our environment? What can we use to go from there? Because our final goal is to get full ownership of the cluster, right? So one of the things we can check is, okay, what operating system are we running on? So via a simple cat, you can figure that out. That already provides you with a lot of information. Because maybe that Alpine Linux distribution happens to have some vulnerability that isn't patched, and that you might take advantage of via some framework, like, for example, Metasploit. We're not going to go into this because it'd be boring just seeing Metasploit things, but that might already be a additional step you might take. Second of all, we might want to figure out, okay, what hardware are we running on, right? There's hardware-based attacks, so maybe that Intel CPU or the software that runs on it is not patched for the Spectre or the Meltdown vulnerability, so you might take advantage of this. And lastly, that's essentially how you figure out that you're running on Kubernetes or within a container. I mean, there's many ways to figure this out, but an easy way is essentially Kubernetes mounts service account information within every container that starts by default. You can essentially turn this off, but by default it does. And it conveniently stores it always, that information in the same path. And you can essentially just read the files there. There's information like your JOT token to connect against the Kubernetes API. There's information like the namespace you're running in, right? That's already something super useful for us to know, to later on take advantage of. So we can see here we're running in Kubernetes, and we're running in a container that's called, in a namespace called pawn.me, right? So that's very interesting information. Another very important thing is, can we access the internet from that container? That's a very big deal, because if we can access the internet, it means we can connect to a server that might host software that we can pull down onto that container. We might connect to a command and control server to actually persist our access or whatever. So having access to the internet is something very interesting for us within the container. And so we can try to ping Google, and as you can see, no problem. We have 0% package loss, so we can access the internet, or at least some parts of it. And finally, package managers. Package managers are super useful for us to pull tools, especially if we have access to internet. Now here I put webget. Everyone's going to say, well, that's not a package manager, it's just to pull data, like websites from the internet. But a package manager doesn't do much more than pull data and store it at specific parts of your system. So with webget, we might already be able to pull everything we need. Any tool that we want, we can cross-compile it for Alpine Linux somewhere, put it on a host, and then just download it with webget. It's potentially a pain because you might need to download lots of things, but it's already enough. Now, me personally, I don't like webget. I prefer curl. Don't know why. But so I checked, okay, is there curl? Well, curl wasn't there. And so I used the actual Alpine package manager to install it, right? So I updated the index with APK update, and then I used APK add curl and installed curl in all the dependencies. So there I can actually use a full package manager to install the tools I want. In this case curl. There's no reason for this to be there. It shouldn't be in there. But it is because people kept the image as is, and so I can install any software I want. But to show you that I don't actually need APK to install curl, I'll use curl to install an additional tool, which is called Cubecontrol. Hopefully most of you know it. It's used to interact with the Kubernetes API. So I can create a little folder called var attack. It's very inconspicuous. No one's going to realize that it's a bad thing. And I just pull kubectl, like a statically already compiled version of kubectl that's hosted on the Kubernetes downloads page, and pull it into the directory, and then I make it executable so I can use it. And that's how you can also install tools. Now, obviously, this is super easy because it doesn't have additional dependencies. If it had more dependencies, it might be more of a pain, and you need to download more things. But that's to show you, you don't need APK access to download stuff and install software. Well, at this point, okay, I have kubectl, so I can access the API because Kubernetes conveniently configures all containers to already contain all the information it needs to connect to it. So it will automatically use the service account that's mounted in the container, and it will automatically know what endpoint to contact the Kubernetes API. So at this point, I know that I'm in the pawn me namespace, right? I checked that before. So I can figure out, okay, what permissions do I have on the Kubernetes cluster? So I can do that with the kubectl auth command, and I want to essentially just list my permissions on that namespace, on the pawn namespace. And now we can see here that we have some permissions on pods. Okay, that's extremely weird scrolling. But essentially, I can create, list, get, and delete pods in that namespace. That's super useful information for us, right? Because that's something we can take advantage of. So how could we have protected ourselves against that type of exploration, against finding all that information within the container? And the most important thing that people disregard for some reason is to remove bloat from your containers. That's what I meant before with safe languages. If you can compile your application to a static binary that doesn't require dependencies, you can push them in a container that essentially contains nothing except that binary. And that way, people cannot pop shells because there's not going to be shells in there. There's not going to be package managers. There's not going to be any way to access the internet because there's not going to be something like webget curl or whatever application they might use to connect to the internet. So remove bloat as much as possible. For example, in a standard Java runtime environment image, like the official image from Java, there is a shell in the container. And there's no reason for it to be in there. So remove as much bloat as possible. The second thing is don't run containers as root. It's what everybody says. In this case, it wouldn't have helped you because I only used root to actually run my APK command, right? And I didn't need to do that. I could have just downloaded kubectl with webget, and I wouldn't have had to run any container with any command with root. But generally, it's still a good practice to not run containers as root. The third point is restrict network access. Unless your application has very good reasons to access the internet, don't allow it to, deny it. Kubernetes supports stuff like network policies that allow you to control egress traffic. So if your application needs internet traffic, then only allow it to the destination that it needs. If there's no reason to access, and there's probably no reason to access wherever the APK index is hosted or any of the mirrors, don't allow your application to do this. Restrict it with network policies. The fourth point is we gained access to an application, and And that application had already privileged access to the Kubernetes API, right? Not much, you can create pods and delete them, it's not like a major deal. But still, any service that is directly exposed over the internet, try not to have it access to the Kubernetes API, if possible. And if it's not possible to essentially isolate that access from the application that is exposed to the internet, then use the principle of least privilege. Now, maybe in this case, the application actually does need to create, delete, create, delete, list, and get pods. But unless it really requires those permissions, essentially don't allow it to. Okay, so we're still in that small container. We haven't gone very far. Actually, we've gone nowhere so far. We just have gathered a bunch of information. And at this point, what we want to do is move laterally through the cluster, right? So we might want to connect to a different container and see what's the permissions that we can take advantage of there? What's the information we can gather there? Can we take advantage of vulnerability on a different container? And this is what we're going to want to look at. And the vulnerability that we're going to use, which is not really a vulnerability per se, is all the tools that we have access to, which is essentially anything we want because we can install it via the package manager, and the actual API access to the Kubernetes API, right? So those aren't strictly vulnerabilities, but it's something we can take advantage of and exploit. So currently, as I said, we're still in that small container. We've gone nowhere. And our current objective is essentially to move laterally in the cluster. It doesn't have to be to a different node. We just want to go elsewhere into a pod potentially that we can control. And ideally, since we can create pods, we can essentially engineer the pod so that we can escape the pod and escape the container onto the Kubernetes node itself, right? And so we get to payload engineering. How are we going to design a pod that we can create such that we can connect to it and then escape to it on the node? And you saw we cannot exec into a container or anything. So an easy way to connect to a container is to run a SSH daemon inside the container, and then you just connect via SSH. Now this is not strictly necessary. We could have used a reverse shell via command and control server or whatever. But it's just the easiest to show is just to start a SSH daemon somewhere else in a pod and then connect to it. So I looked on Docker Hub for containers that contain SSH daemons. Turns out there's actually very few, which makes sense because there's no real reason to start an SSH daemon in a container unless you're doing something very dodgy. But I did find one from some dude called Panubo. I don't know him. No one knows him, I guess. Or maybe someone knows him, but my point is it's not an official image or anything. It's not verified. So Docker Hub doesn't know anything about that image, just someone that pushed it. So I first inspected it, that it doesn't do anything weird, and tried to figure out how it works. So essentially how it works, you can see here, pretty simple. It starts the daemon, provides it with the configuration. So I used that image. I was like, okay, I'm going to need to connect to it, obviously, at some point. So first I install OpenSSH, so I have an SSH client in my container, right? I'm still at the top, you can see I'm still in the red small container. So I installed OpenSSH, so I have a SSH client and some tools that I might use. One of those tools is SSH keygen, so I want to generate SSH keys so that I can register that key into that container that I'm going to connect to, and I get permission to access it, right? So I generate my keys, and then I print my RSA public key, because that's what I'm going to register as an authorized key in the container I'm going to essentially create against the Kubernetes API. So this is essentially my payload. Once I've created that certificate, or that certificate pair, I guess, I create a pod. I deploy it in the namespace pawn.me, or I'm going to deploy it in the namespace pawn.me, because that's where I know that I have the permissions, right? And at the moment, it's the only namespace I know exists. I don't know the names of the other namespaces. Now I need to set that environment variable on the container that I'm going to create so that I get actually access as root, which is something I do want, right? Always you want as much permission as possible. That's documentation on Docker Hub. You can find out on that Panubo image. Turns out if you set that flag, you're going to be logged in as root. And finally, I changed the command because I want to essentially print my key into the authorized keys so that when I log in with my private key, I essentially directly get access, right? So I slightly modify the command to essentially print that key into the authorized keys first. Now I have a container that I could, in theory, connect to, but I don't have that vulnerable container that allows me to escape onto a node, right? And one very popular way to escape containers onto nodes is essentially to mount the entire host file system into your container. And so this is what I try here. So I define a volume that contains a host path that references essentially the root file system of the node that this is going to run on, and now mount it somewhere in my container. So in this case, under SVR host. And at this point, I try to apply it. So I do payload injection, fancy name for create the pod against the Kubernetes API. And lo and behold, it gets created, no problem, and it's running. Now I can see here I have the IP that I can use to access my SSH container, right? Or pod in this case. So I SSH against that IP, and I'm connected. So you can see at the top now, I essentially performed that lateral movement, right? So I moved from my initial container with the initial vulnerability onto a new pod that I created to perform lateral movement, and that pod I control because I configured it, right? And so I configured in a way that makes it vulnerable, and this is what essentially I wanted to achieve with this. So then I'm still in my container. At this point, I can perform a change root onto SVR host. And at that point, I'm actually in the file system of the host, of the node that runs the container, right? So you can see at the top, I essentially escaped the pod, and I'm now essentially running software on the node itself. So I can check, for example, what the host name is. This is something I might be very interested in because it might gives me information about what the node is called, right? Which might be interesting for later on referencing other nodes. So it's called K3D Pipeline Cluster Agent 2. That gives me some information. Okay, I landed probably on a worker node because it's called agent. K3D already gives me information what kind of Kubernetes distribution I'm running in. We'll see that later. And the most important part, I can check my user ID. And because I was root in the container when I escaped, I kept the user ID 0, so there was no mapping performed between the container and the host. So I'm actually root on the node file system at this point. So I can do whatever I want on that node. I essentially own the node, all right? So this is already super nice because that means I can look, okay, what other containers are running in there? I can perform a memory dump to get secrets. I can wreak havoc. I could just like shut it down if I wanted to. I mean, it wouldn't help much, or at least it wouldn't help me get access to the entire cluster, but I could already do some pretty decent damage. So at this point, we're here, right? We took full ownership of a node. Useful, not useful, debatable, but this is not our main objective, right? Our main objective is to gain full access, so we're not going to stop here. But how could we have protected ourselves against this? So again, use network policies, restrict access. I created a node and I could, created a pod, sorry, and containers running in that pod, and I could easily connect to it. Why can my initial application that had the remote code execution vulnerability, why can it connect to any pod? Doesn't make sense. It should be something that is explicitly given that permission. So use network policies to restrict how your network behaves and what your applications can connect to. It's very important. The second thing is never allow host path mounts in your containers. There's very few use cases that make sense where you need this, such as log forwarding. And in that case, your platform team might do this once and then essentially revoke permission to do this everywhere, because there is no real good use case for any application developer to need a host path mount. So disallow this at all costs. And last, use a proxy container registry. What I mean by that is, how come I can pull any image from Docker Hub and essentially deploy it on my container? This is super unsecure because it exposes you to so many supply chain attacks. There should be a proxy registry that essentially verifies that when I try to access Docker Hub, it's at least a verified image or something, or maybe just disallow it fully and say, no, you're not allowed to pull from public registries. You have to pull from your company's internal registry of images that your company like essentially built, scans, and controls. But at least if you allow public, like pulls from public registries, use a proxy that verifies that it's an official or verified image and not some random image. Okay. So we're still now nodes. We got some information such as the host name, but we want to find more information, right? So one of those things is process listing. So I can perform a process listing on my node, right? And I can see every process that's running as every user. And here again, I see some useful information. For example, what Kubernetes distribution am I running? So I'm running K3S agent apparently. So I'm actually running that inside. It's virtualized, so that's why there's some Docker stuff as well. But essentially, I found information about what Kubernetes distribution is running. I could find version information of this. This is something I can exploit, right? Because I can figure out how does K3S work. Just go online, read all the documentation you can find, and then you have a lot of information about how those nodes are like built up and what kind of files there exists and what you can take advantage of. So yeah, this is essentially the information I get from this. Then I can do some basic searching for files on the file system. So I didn't know that there was some file called etc rancher node password. I essentially did I didn't show it here, but I essentially did a find on the entire file system, looking for looking for files that are called password or PW or contain shadow in it. And one of those files I found many, but one of them had what seems to be a plain text password stored in it. So this is also information I can use later on. Now I'm not going to use it because, well, I didn't want to figure out what it was, and there's easier ways to go about it. But this is probably something I can use to gain more access and essentially escalate my privileges. And another thing I did is I looked for configurations that were related to Kubernetes, because typically on Kubernetes nodes, there's a lot of configuration about Kubernetes that you might use to, I don't know, get certificate data, for example, or figure out what the endpoints are listening and so on. And so I just listed them, and I looked at a few of them. Contain some interesting information, such as where, for example, keys might be lying and so on. But I tried to connect it like very briefly with that configuration, connect to the endpoint, and it didn't work. And then I sort of abandoned that idea because the chances that it provides me full access is very small since I'm on a worker node. So I thought about trying something else. And there's something else I tried. I was like, okay, we're on a worker node right now, but maybe we can essentially just schedule our pod, right? The pod that we created on a master node, because sometimes that is allowed. And at that point, if I can escape the same way, the container that I know works, right? Then I'm on a master node and not on a worker node. And there might be much more interesting information and much more like scary stuff, I guess, for the cluster administrator. So my goal here is essentially to access a control plane node, so a master node, right? And from there, then gain privileged access to the API. So we're still there, and essentially our goal is to shift the whole thing and get access to a master node. And so we knew the host name of the node that we just accessed, right? So we might try to modify that name with the node affinity to connect to the other one. So how we do this is we go back out of our change route, right? This is the first exit. Then the second exit is we terminate the SSH connection. And then I deleted the pod because I want to recreate essentially the same one somewhere else. So we get back to our little pod definition. Essentially what we can define is a node affinity, right? So this tells Kubernetes, okay, where should that node be scheduled? And I knew already the host name of my worker node, right? It was K3D pipeline cluster agent 2. And so I looked up on K3S online how it calls its master nodes, and turns out it calls it server and the worker node's agent. So I just tried, okay, K3D pipeline cluster server 0. If there is a master node, it's probably going to be under that name. Again, I create the pod, and again, it works. And you can see there is a pod running now on a master node. Here again, I can SSH to the IP, right? I can see, because I can list my pods, I can do my change route, and verify that I'm actually on that node, and I am on a node running server. Now I can also, again, verify, is this actually a master node or not? I'm not going to go into details of how you can do this, but essentially, trust me that this is a master node. How could we have protected ourselves against this? Well, the main thing is never allow scheduling of pods on control plane nodes. Unfortunately, lots of people that start with Kubernetes start with small clusters that might only have a couple nodes, and potentially they even have redundant masternodes. They have 3 masternodes, and then they see their cluster and see, okay, half of my cluster is control plane nodes. It's such a shame. We have that CPU and memory just lying around doing little, and then they allow essentially their pods to get connected or to get scheduled on the control plane nodes, just to save resources. And they say, yeah, it's fine, it's just a test cluster. We're going to change it later on when we go productive with it. But still, don't do this, because people can hack you, even your test clusters can get hacked, and you can get useful information from that to later on hack productive clusters. Or even if someone takes over your test cluster, it might already be very damaging for you or your company. So under no circumstance, even if it's a test cluster or whatever, never allow to schedule nodes, schedule pods, sorry, on your control plane nodes. And that's how this could have been avoided. So post-exploitation, we're on the master nodes. We don't have full cluster access, right, at this point. But we want to gain full cluster access. So we need to find out more information again. We're on the master node. There might be more interesting information than on the worker nodes. So again, we explore a bit, look for files. I know that now that it's running a K3s distribution, so I know where important files might be. And I found out on Google that there's that file on masternodes called under etc rancher k3s.yaml, which is essentially a highly privileged configuration of how to connect to the Kubernetes API. And so I look for it, and lo and behold, it is there. It contains a client key data and some client key, some client certificates that allow me to essentially authenticate against the Kubernetes API. So I tried this, and unfortunately the connection got rejected. So I was like, well, this is sad. Apparently there was a problem with the host name, or the interface I was listening on was not happy with the host name I was providing. So I decided, okay, let's change the host name, which is essentially localhost 27001, to the name of the actual host. So I know the actual host name, right? Which is K3D pipeline cluster server 0. So I just modify the Kubernetes configuration and use it. So you can export it as an environment variable. And you don't even need to install kubectl. That's a great thing on K3s. The nodes already contain kubectl installed, so no need to install it. And I can check, okay, again, what permissions do I have with that account? Now, I chose the kube system namespace to check my permissions, because this is the most protected, or typically the most protected namespace in your entire cluster, because it runs all the system software that Kubernetes needs to do what it does. And look at this. I have, ooh, shit, something fell down. I have on any API, I can do whatever I want. So at this point, I'm cluster administrator of the Kubernetes cluster. I can do whatever I want, right? And on top of having access to the Kubernetes cluster and being like essentially cluster administrator via the API, I also have access to the nodes themselves via the container escape to be full admin, or to be root essentially on the nodes. This is something super important, because in a real hack you wouldn't go through it like this, because you're leaving lots of traces, right? Audit logs and so on. And by getting access to the nodes themselves, you can essentially wipe audit logs or modify them to hide that you ever connected to the cluster, hide that the pods were created for the SSH daemon and so on. So gaining access to the physical nodes on which Kubernetes is running is something extremely useful. At this point, we have full access, so we reached whatever we wanted to do. At this point, we'd want to create a backdoor, right? We don't want to go through all this trouble every time we want to get full access. Typically, you'd plant several backdoors, one on Kubernetes level, for example, one on node level, one that persists over several ways. This would essentially be the next step. Now, I actually removed those slides because I thought I would not be in time on how you could create such a backdoor, but I might move forward really quickly on how to do this, because I still have time. And essentially, one cool thing that K3s provides is called static manifests. Many people don't know about those, but essentially what they are is K3s manages some resources to ensure that its Kubernetes distribution works the way it's intended to. that contains stuff like configuration of how your DNS service works, some metric servers, some default role bindings that you need. And what it does is essentially it's just a folder where you have those API object definitions, and it periodically applies them. Which means that if you modify, for example, the core DNS configuration on your cluster, even if you're cluster admin and you're allowed to change it, it will get changed back periodically to whatever is defined in there, because K3S in the background essentially applies those things. And what this means is that if I, as a bad actor, put a Kubernetes API object in there, it sort of makes it undeletable on the cluster, right? Because even if someone deletes it, it'll get reapplied afterwards. So someone would need to figure out that it is stored there somewhere and delete the actual file in order to delete it from the Kubernetes cluster. And so a very simple, so this is not how an actual backdoor would look like, but a very simple way to improve our access, to get better access to the Kubernetes API, is essentially to define a role binding. So I can figure out now that I'm cluster admin what the service account is called, that my initial container, right, that contained the remote code execution vulnerability, what the service account was called. And it turns out it's called vulnerable app, because it's the fake environment. And I can create the role binding that essentially binds the cluster admin cluster role to that service account, which means that at this point I essentially escalate the privileges of the vulnerable application so that from my remote code execution vulnerability that I found, I can essentially directly get admin privileges on the cluster, and I don't need to go through the SSH connection and then the container escape. Another way would essentially be to exfiltrate the data of the configuration that we just found. So typically this would not be how you design a backdoor, because you still need to take advantage of the remote code execution vulnerability, which is a bit of a pain because they might get fixed, right? And someone might see this, because this is very obvious that it's not meant, that it's not a proper role binding, because it provides cluster access to a service account, which is the worst thing that you could possibly do in Kubernetes. But it would be a way to essentially make our access simpler. Now I'm going to quickly go back to my learnings. Yes. The learnings I hope you get from this is, the first thing is we can't prevent this. All right? Kubernetes is a very complex system that has very intricate, mechanisms, I guess. And we're human, right? So when we develop stuff on Kubernetes, mistakes are going to happen. It's just bound to be the case. And the infrastructure on Kubernetes, so your pods and containers, it's a very chaotic environment. So figuring out, okay, what is proper and what might be a bad actor doing something is very difficult to find. However, we can make such vulnerabilities much more difficult to exploit, right? So that when a mistake happens, the impact is much, much smaller. And the main thing is obviously get informed. The better you know Kubernetes, the less likely you are to make a major mistake. But also monitor everything you do, right? Or everything that is being done on the Kubernetes cluster. For example, the application we accessed at the very beginning, where we took advantage of the remote code execution, right? If you monitor the traffic, the network traffic that comes and goes from that application, and you suddenly see, I think, 44 megabyte package being pulled from the Kubernetes download page, you know something's wrong, right? This should pop a red flag. Someone should get informed from that. So monitor traffic, network traffic. Monitor CPU usage. Monitor everything. And as soon as something is not normal or seems to be not normal, investigate it. And lastly, deny by default. This is essentially what I talked about before with the network policies. Unless there's a majorly good reason for an application to be provided some privileges, which might mean connecting to some host, which might mean having access to the Kubernetes API, just don't allow it. Deny it, and make sure that your application teams need to request those privileges from a platform team that know what they're doing, and then provide them the access if it's needed and if it's secure. And essentially, with everything in security, it's mostly a question of mindset. The first thing when you're working on Kubernetes is always assume Kubernetes is already been breached. Don't deploy applications on Kubernetes that trust the application from the team that's sitting across the office from you because you know them, they're good guys, there's no reason to send a malicious request to your application because maybe they've been compromised already, right? Maybe their application has already been hacked. So always assume that your cluster has already been breached and build your application according to this. This also steps into the zero trust mentality, right? Don't trust anything within the cluster. People tend to think Kubernetes is that nice little enclave where you can trust everything. You don't need authentication within your cluster because it's only the company that works on it. No, don't trust anything. And lastly, if you're really in doubt and you don't know what to do, get help. There's an amazing community that supports people that are new to Kubernetes and are new to the security aspects of it that you can take advantage of. Obviously, there's companies that provide consulting for it and so on. There's certifications you can do from the Cloud Native Foundation on Kubernetes security, like focus specifically on the security aspect of Kubernetes. So book a course, get certified. Yeah, learn your stuff. And with that, this is the end of my talk. Thank you very much. And we still have a bit of time for questions. So if there's anything that was unclear or if someone has a question, I'd be happy to answer it.
So just detail about the container breakouts when you do chroot. That only works if the user namespace is the same
exactly
across containers, right?
So no, it doesn't necessarily. It still works if the user namespace is not the same, but you'll not be root when you escape, essentially. So if your user ID gets mapped, which it should be, then you'll still be able to escape, but you'll be some random user 16,000 something. And typically, in reality, your container escape would look slightly different. In reality, you would use a CVE from, for example, Cryo to escape, because a host path mount on most common distributions is not allowed by default. But K3S, for example, allows it by default. Unless you explicitly configure it not to allow this, you'll be allowed to do this. Yeah.
Thank you.
No worries. All right. No more questions? All right, cool. Then thank you very much. And have a nice remaining of the conference, I guess.